Hello everyone, I welcome you all to this lecture. In this lecture, we are going to discuss the further part of security at the network layer with respect to IPsec protocol. In the previous lecture, we had discussed security at the network layer. So there we are using IPsec, under which two protocols we discussed are authentication header and ESP, encapsulating security payload, and they are working both in a tunnel mode or in a transport mode. Now, in this lecture, we are going to discuss Internet Key Exchange Protocol. So, the main goal of Internet Key Exchange Protocol is to establish an security association between two parties that wish to communicate securely using IP security. There will be a security association must be established between the communicating parties that will be bringing the knowledge of about lifetime, maybe a mode in which they are operating, such as the tunnel or the transport mode, and the cryptographic parameter exchanged between the parties, and it is bringing also the anti-replay window information, and the sequence numbers are associated with the packet numbers. These kind of information must be maintained as a knowledge or information in terms of security association database, SADB database at every node which is involving in the secure fashion communication. Now, the main goal of Internet Key Exchange Protocol, that is IKE, which is to establish such security association between the parties that wish to communicate securely using the IP security protocol. But here, one notable thing is IPsec is a network layer protocol, whereas Internet Key Exchange Protocol is an application layer protocol using connectionless user datagram protocol with the port number 500. IP security is a network layer protocol, whereas IKE is application layer protocol. Now, IKE is comprised of two phases. So there, the communication must be taking place in terms of the two phases. In the first phase, an IKE security association is established. This creates a secure channel upon which the communicating parties that can help establish multiple IPsec security association instances over a time period. So the first thing is we need to establish SCA, and the one node which will be taking an initiation is the initiator, and the other party which will be responding to that will be considered as the responder. In the further discussion, we need to understand these wordings, initiator and the responder. Now, it is good security practice to periodically change cryptographic keys used by two communicating parties. We need to frequently uh, change the cryptographic keys used by the communicating parties. In phase 1, longer term keys are derived, and phase 1 occurs rarely and is more computationally intensive as compared to phase 2. In phase 2, we are using shorter term keys, which are the derivatives of the keys which are used in the first phase. So here the shorter term keys are said to be keys which are the function of the long term keys which are computed in the phase 1, along with the nonces or the random integers or the challenge values exchanged in the phase 2. So very little introduction is this Internet Key Exchange Protocol. Now let us discuss both of these two phases in detail along with the diagrams. So before that, I would like to bring one more knowledge. So with the IKE protocol, where if an attacker tries to trap the line between the two parties, say for example A and B, the attacker will have no way to spoof the cookie which is created in the response to a request from any party, that is A or by B. So here we are trying to overcome the problem of a spoofing, where the attacker is able to act as a known source. Being unknown to someone, he will be trying to act as a known source. Here such kind of attacks are overcome by the IKE protocol. So for the same we required the cookies. So let us discuss the IPsec cookies. Now, to prevent DOS attacks, IKE definitely makes extensive use of cookies. So simply the cookie or HTTP cookie or internet cookies are simply a small piece of data that is continuously brought into the user's machine or a computer through the web browsers what the user is using. Now that information used by the web servers or the websites to keep track of the user's activity, means these cookies are helping to maintain stateful information about the users. For example, what the user was logged in previously, to which form the user logged into, and what are the website he was visited in the past hours or past days. These kind of information or closing or opening of a particular files, so such kind of information can be maintained as a stateful information. These are handled by the cookies. So here definitely the IKE makes use of the such internet cookies to prevent the DOS attacks. So one cookie is created by the initiator A and another by the responder B. So you can take the one which will begins with the establishing a such security communication channel, establishing such a secure channel, or which will send a first message, that will be called as the initiator, and the one which will be later was responding, that will be called as responder. In this case it is B, we can consider. Now phase 1 of IKE uses Diffie Hellman key exchange protocol. So here actually this is the concept is there in the second model. It is coming under discrete logarithmic function, where there will be a one common session key will be established which are agreed upon by both the parties, that will be used for the further encrypting messages or the subsequent message exchange between the parties. So there it will be based on the modular exponentiation. So for example, there we are using the equation such as g to the power a into mod p and g to the power b into mod p, where g is the generator which is commonly known to a and b. Then small a, b, these things are indicating they are the values, the secret values or randomly selected values can be uh, chosen by a and b, and p is a prime number you can take for example. So such kind of values can be computed, and finally they are going to compute one common secret key. So that is there with the Diffie-Hellman concept. So again I suggest you to refer module 2, the discrete logarithm, in that section Diffie-Hellman key exchange protocol, which I have shared with you through one of the video which is posted in the Google Classroom. Now the definitely IKE in phase 1 it will use the Diffie-Hellman key exchange protocol, which involves the computationally intense modular exponentiation operation. uh, and here IKE mandates that responder should compute a 64 integer called a cookie. So now how the cookies can be identified is by a 64 integer. So that is what the cookie, you can call it as the ID also. This is a hash function of many variables including the IP address of A and temporary secret known only to B and possibly the time. A is required to send this cookie to B in all subsequent messages. On receipt of a message from A, B will check to see whether the cookie corresponds to A's IP address. If the check fails, then B will abort the session establishment. So B will further, it will not continue establishing a session with the A. So the B need to check to see that whether the cookie corresponds to A's IP address is true or not. If it is fails, then B definitely is coming out of the session establishment procedure. So this is what the basic idea behind the IKE protocol. Now here let us have the IKE phase 1 in detail with the diagrams. Just ignore again the figure number 13.4, just it is okay. That they copied this diagram from the prescribed textbook. It is IKE phase 1 which is working in the main mode. So later I would like to bring you on the knowledge what is the main mode and the aggressive mode. So let us have the main mode first. Here the cookie computed by B, that is I can denote as CB in terms of this. Here you can look onto. So this CB, it is a cookie created by B. Then is sent in message 2. So what will happen? So the first thing is, first A, if it is the initiator, then it will be sending its cookie. Then there will be another uh, variable what I can consider as security association with respect to A. SK means security association. Since the message is from A to B, so I can write like this. So after this, the cookie computed by B, that is CB, is sent in message 2 and must be included in all messages sent by either party thereafter. In a similar manner, a cookie CA is initially created by A and subsequently sent in all messages. So as we are seeing in the first two messages 1 and 2, here we are able to see CA and CB, so they can be transmitted, okay, from one to another party. The pair CA comma CB plays the role in IKE that the security policy index plays in IP security. So try to recall, there is a parameter called security parameter index. So that is a key role in case of the IP security protocol. Here the cookies CA and CB, they will be a very important key roles in case of the IKE, Internet Key Exchange protocol. Now what will happen in IKE phase 1? The authentication method, encryption and hash algorithm together with the DEF element group to be used are negotiated. So here what I'll be showing again. So here definitely, okay, there we must be using the letter words, the encryption hash algorithm along with the diffie element group are to be used for the negotiated, means that knowledge is brought to the other party to which we wanted to establish a communication session. Now both parties authenticate themselves to each other. Both parties authenticate themselves to each other by exchanging such an information. Now here cookies are created at the start of the phase 1 and serve the purpose of an IKE connections identifier. So the cookies here able to serve the purpose of connections identifier. So now here I would like to bring you in the knowledge main mode and the aggressive mode. The aggressive mode, which we are going to discuss later. Phase 1 uses one of the two modes, that is either main mode or aggressive. Main mode involves total of 6 messages exchanged between the initiator and the responder. So initiator A and responder B, they are going to exchange 6 messages, namely 1, 2, 3, 4, 5, 6, as shown in the diagram A. Now while in case of aggressive mode, that uses only 3 messages. So in the aggressive mode, that I am going to cover it in the next slide, so which is going to have only exchange of the 3 messages between the initiator and the responder, that can be discussed later. Now the motivation for introducing main mode is to hide the identifiers of the sender and the receiver from eavesdroppers. So where in the main mode we are trying to hide the identifiers of the sender and the receiver from an attacker or eavesdroppers. Again at the end you only are going to conclude the main, it is a main advantage of the main mode than the aggressive method. Now to perform a mutual authentication, IK assumes that either A and B share a secret, that is pre-sharing of a key. Before the actual communication, they are sharing a key. That is why we are calling it as pre-shared key. And again, we are using the two more options, the private signature key or the private decryption key. So these are the two more options. Now here let us discuss. Okay, so these all things I will be considering as uh, option 1, option 2 and option 3. In option 1, this is the diagram 13.4, okay, that is A, shows the sequence of messages exchanged between A and B under the assumptions that A and B share a secret key. That is, yes, here it is not shown, but understand there will be a secret key which is lies, that is S, that can be shared between both A and B. The first message contains the cryptographic algorithms proposed by A for use in the IKE security association. That is what the cookie CA. This is denoted SA of A. Okay, so security association must be established. That is SAA. Now message 2 shows the cryptographic algorithms accepted by B. That is SAB and CB along with CA what it was received in the previous step. Now in message 3 and 4 both sides exchange nonces. So here coming to the third and fourth, so there along with this CA, CB and the diffie element parameter, that is g to the power A, and diffie element parameter g to the power B. uh, so there an additional variable what we required is the nonce or the random integer, okay, RA and RB by both A and B respectively. So in message 3 and 4 both sides there will be an exchanging of such random integers and diffie element partial keys. That is what I told, the g to the power A, here it is g to the power A and g to the power B. These are the partial keys actually, okay, diffie element partial keys that can be exchanged. After the message 4 has been received, A and B independently compute a hierarchy of secrets. So here what happens is, after receiving all of this in the fifth and sixth message, what happens is there are the set of keys, the hierarchy of secrets will be derived. So for the same again I would like to suggest you to refer the prescribed textbook. So there they are given the equations. There we are using the pseudo random functions to produce the shared secret keys. Now in the fifth message what happens is both A and B use a MAC, so that is message authentication code, along with all this the familiar, okay. So, what A and B use is MAC, message authentication code, for the purpose of the authentication and integrity. So here these are denoted by MAC A, these are denoted by MAC A and MAC B. So in the fifth and sixth message what is the main thing is, we need to ensure authenticity and integrity. That is in the message 5 we are using MAC A and in the message 6 we are using MAC B. Note that the key used in the computation of the MAC is a key suffix A, which is a function of the shared secret key S between A and B. So here I am unable to show the secret value, that is S. I again suggest you to refer the textbook for that, but there will be definitely a shared secret key S will be there behind this, okay. Along with that there are hierarchy of the shared secret keys can be generated with the help of this knowledge. But for your examination point of view, you can refer only this much. There will be a cookies can be generated by A and B along with the security association establishment between A and B in the form of this. Then the partial keys of diffie element along with the random integer can be exchanged between A and B in the third and fourth message. And in the fifth and sixth, okay, we have to use the message authentication codes by A and B. So after this, okay, there will be an secure communication channel can be established. So the session by exchanging a subsequent messages will be taken over such a channel. So that is with the first option. Now there will be a major drawback with this option involving a shared secret. Consider what happens when B receives message 5. He must first decrypt the message, but for that he needs to use secret key, that is S, that he shares with A. To use S, he needs to know the identity of the message sender. However, the sender's ID is itself encrypted. One possibility is to use the source IP address to identify the sender. But if the IP address is a giveaway of the sender's identity, then what was the point in protecting the sender's identity using encryption? So this is a major drawback with the option 1. So now alternatively, B could keep track of all the entities that it expects to communicate with from each IP address. Then when an IKE request arrives from a particular IP address, it could attempt to decrypt the message using secret it shares with each entity at the IP address. A message would be successfully decrypted if the key is used for decryption matched that shared by entity whose ID appeared in message 5. So this is a major drawback with the option 1. To overcome this, we are using the another option, that is option 2, by using private signature key. So here A and B each have private signature or the signing keys. The sequence of message section between A and B as shown in figure B of this diagram. Here this figure is very similar to that of the previous one, that is A. The main difference is that authentication and integrity protection of messages is affected by digital signatures on MAC A and MAC B using their private keys. The main difference between this and this diagram is there we are going to have the main difference is authentication and integrity protection of message is affected by the use of digital signatures on MAC A and MAC B. So instead of that, there we required a digital certificates, digital signatures using their private keys. Also, A and B dispatch their signing key certificates in message 5 and 6, so the other party can perform signature verification. So here, what is the difference is you can see almost first, second, third, and four they are same. Only changes is in the fifth and sixth step. Okay, as compared to this diagram, here what we are using is instead of MAC, what we are using is the certificate, means the digitally signed certificates. Okay, instead of the MAC A and MAC B, we are using certificate of A and certificate of B. Along with that, the private signature key, that is the SIG suffix A and SIG suffix B. This indicates the private signature key of A and private signature key of B. So these in the encrypted manner can be transmitted from A to B in the fifth message and B to A in the sixth message. That is the only difference. So now this is the second option, to use the IKE phase 1 in the main mode. So now coming to the option 3, where A and B each have private decryption key. So there is a use of the private decryption key as shown in this diagram named C. The first two messages used with this option are as in the two previous cases. The first two messages are same. The main difference between this option and the previous one is that both sides exchange their identifiers earlier in message 3 and 4. Each side generates the nonce RA and RB as shown here. Each side we are using the RA and RB and decrypts it with the other side's public key. So there will be a decryption is needed to takes place by using the by using okay. So here each side generates a nonce, that is RA and RB, and encrypts it with the other side public key. Each side encrypts its identity together with the Diffie-Hellman partial keys, that is G to the power A into mod P and G to the power B into mod P, with temporary keys Ka and Kb in messages 3 and 4. Here you can see, okay, in the third and fourth message where we are using the temporary keys K and Kb in message 3 and 4 respectively. Okay, again you can take an example. Here the public key we are using for the encryption. Okay, that is again the input parameter we required are the RA, here it is RB. Along with that, the Diffie-Hellman partial key and A's identity, Diffie-Hellman partial key and B's identification details can be sent, okay, along with the cookies. The cookies are used in all these options, but here there is a use of the private decryption key is required for the decryption, and the same public key value must be supplied by the same party. Okay, so for the decryption we are using the private decryption key, and the public key knowledge must be shared with the other parties. That is the one thing which is the difference between the second and the first option. Now in message 5 and 6 each side transmits a MAC, so there will be again a MAC is going to be used in the message 5 and message 6. So here to say in figure A, B, C, in B and C we are not showing the message numbers, but these 1 2 3 4 5 6 they remain same. So there always the six messages are going to be established, sorry, six messages are going to be exchanged between the parties before their actual communication. So again in the fifth and sixth, the both sides they will transmit the message authentication codes along with the other things, that is such as CA and CB, CA and CB. Okay, so this thing, so this completes the procedure of the first phase. Now, so in the aggressive mode, what happens is there are only the six, sorry, instead of six messages here we are using only exchange of the three messages. The one major difference in the aggressive mode, it is more, uh, there will be more chance that you are you are not hiding an information. So instead of the six messages, it is showing in a single message several parameters like the cookie and the security association, the defilement partial key, the nonce, and the identity details of A, etc. can be sent or transmitted from one party to other party in a single step. So this is more exposing attack, so we'll be preferring to use the main mode, okay, for the IK phase 1 than the aggressive mode. I do not wanted to cover again the two more options. These are almost same as that of the previous, but only three messages are going to be exchanged in case of the aggressive mode. So now after this phase 1 in the main mode, or either, okay, either in the main mode or aggressive mode, second phase, two parties participate in an IK phase 2 exchange in order to establish a new IP security association. IP security association, either party can initiate this phase in which the cipher suit and the keys that comprise the new IP security association are agreed upon. So the following figure shows IK phase 2. Here, so this again CACB MID, here the message ID is this. Okay, the remaining things I already told you in the previous class. So now a 32-bit message ID, that is MID, is used to distinguish this phase 2 session from the possibly others that may be set up concurrently within the same IKE security association. The message identifier MID together with the two cookies created in phase 1, those are respectively CA and CB, are dispatched as part of each of the three messages. Both sides send their proposals for a suite of cryptographic algorithms to be used in the IP security association. These are denoted as SA suffix A, SA suffix A, and SA suffix B in the next message. To guarantee freshness, both sides also generates and transmit the nonces NA and NB. So there we are using the two nonces NA and NB respectively by A and B. In addition to the agreement on a cryptographic suit, the purpose of this phase is to agree on the secrets to be used for authentication. As part of the IP security association, these secrets are computed simultaneously by both sides, are a function of a secret key, one of the secret key, that is key suffix D, which I am not able to show in this diagram, that is computed in phase 1, and nonces NA and NB exchange in this phase. So that is what going to take place. Now there will be another variable we are introducing here with the phase 2 is MID. Now uh, the IP security association setup in phase 2, that includes the mutually agreed upon cryptographic suite and secret keys for authentication or and encryption. Both sides will then create an entry for the new security association in their databases of SES. So this is what the second phase. By this, both the parties, they are after establishing all these things, they are agreeing, okay, that they are going to exchange their messages through a secure communication channel. So now here there might be use of defilement partial keys, the message authentication code, the message identifiers. So everything is important. So exchanging of these kind of information So along with covering the cryptographic parameters in the form of the cipher suit. A suit means a group of parameters which are used for the cryptographic purpose. So that the exchanging of such information is able to make one party to believe the other that they are communicating in a secure fashion. So that is what the internet key exchange protocol. So with this, again, now we'll move on to the next concept, that is security policy and IP security. So here, a security policy database, in short SPD, is used to determine whether a packet sent or received should pass through a security or bypass it or simply be dropped. Such a decision is made based on fields in the IP and the transport headers. So here, the security policy database is used to determine whether the packet to be sent or received, okay, should be considering the security as a factor or bypassing, or simply such packets are need to be dropped. So such a decision is made based on checking every fields of the IP as well as transport headers, either the TCP or the UDP header formats or the IP header. In case of the IPv4 or IPv6, the header formats, the fields can be checked. So there we are having the several information. Now that is the main thing. Now here we need a mechanism to support high level policy statements, such as there's one statement is given in your prescribed textbook: authenticate all web traffic to IP address a.b.c.d. So here it is the IP address in the notation a.b.c.d, which is, you can consider IPv4 format it is. Now what will happen? So uh, here for the same, the SPD database needs to look onto the fields of the IP or the transport headers. These fields are usually called selectors. So that may be including, okay, some of the fields it is including are destination IP address, the type of transport layer protocol, whether TCP or UDP, and type of application indicated by transport selectors are used to index into the security policy database. So here a security policy database is used to determine whether the packet sent, okay, is really uh, uh, considering the security or not. So here the selectors are chosen, and these selectors may be including the destination IP address, the type of the transport layer protocols, and several more information. These selectors are used to index into the security policy database to indicate whether there will be a security issues addressed or not. Now the selectors are used to index into the SPD. The output of this lookup indicates whether security should be applied. If so, and if the packet is part of the IP traffic that already has an existing security association, then the security policy database returns a pointer to that security association. If an SCA does not exist or has expired, then the IKE protocol is used to establish SCA between the sender and the receiver. If such a security association does not exist or has been expired, then the IKE protocol is used to establish a security association between a sender and receiver. So this is what the very simple thing. So there will be a security policy database. There are the selectors are used to check the fields from the IP as well as transport headers, and the lookup procedure, okay, means with the help of the selectors can be done. If so, the packet is part of the IP traffic that are already exist, okay, that are already covered under the security association, then SPD returns a pointer to the security association. Otherwise we need to depend on the internet key exchange protocol, that is the use of the cookies, etc., to believe that the other party is establishing a secure communication with that. Okay, so this is a security policy and the IPsec protocol with its continuation. Now coming to the last concept in this chapter, that is IPsec, security of the network layer, virtual private network. So in short it is VPN. A virtual private network enables organizations to communicate securely over a public, a shared network such as internet. You are all aware that internet. One possibility is to use dedicated point-to-point lines such as T1 leased lines to keep communications confidential. So here what is the use? you can take for example the T1 leased lines. Okay, they will be used to keep the communication very confidential, that can be done only between the parties, or even though it will uses the public channel. Okay, so however there is a clear cost advantages using such a shared public accessible network instead. So here definitely it is having the cost advantage. Okay, you are making use of the public network, that is with the reduced cost or even with the no cost. So the virtual private network. Now the IPsec is just a protocol that helps to secure traffic over such open and insecure networks. So here for definitely creating the virtual private networks, there the protocol we are using, underlying protocol is IPsec. So a secure VPN uses the cryptographic technique to provide not just the confidentiality but authentication and message integrity. So here it is very important. Okay, here a secure VPN, there are the two kinds again I would like to consider: a secure VPN and a trusted VPN. In the secure VPN, that uses the cryptographic techniques, means definitely okay to provide not just the confidentiality but also the authentication and message integrity. But when compared to this, the trusted VPN, where the customer traffic is not usually encrypted. So this is what, okay, the confidentiality in a trusted VPN. Okay, trusted itself saying that there the traffic, okay, coming from the customers is usually not encrypted. The service provider has to guarantee confidentiality of a traffic. So trusted, the name itself indicates there is no encryption method is going to takes, but the service provider should ensure that okay, it is guaranteeing the confidentiality of the customer traffic. So there are two most widely used VPNs are site-to-site VPN and remote access VPN. Okay, the site-to-site VPN, which are used to link multiple offices of an organization, known as intranet. They are widely used to connect multiple branches of a bank also. Okay, the another example you can consider, they are used to connect multiple branches of a bank. A site-to-site VPNs may also be used to secure an extranet. Okay, so understand the difference between the intranet and the extranet comparatively with the internet. So now secure, sorry, a site-to-site VPN may also be used to secure an extranet, a network connecting multiple business partners. Remote access VPNs connect teleworkers, that is mobile users or users from home to other offices. Both site-to-site and remote access VPNs often use IPsec to provide secure communications. In addition, SSL-based VPNs have been deployed. One advantage of SSL-based VPNs is that they do not require any additional software beyond a browser. So this is what the concept called the virtual private networks. The remote access VPNs, they will connect the teleworkers to their offices. So this is exactly like okay SSL based VPNs. So here one advantage of secure socket layer SSL based VPNs is that they do not require any additional software beyond their browser. Thank you.